go over that so you can understand what's appropriate, because you will be asked to do one of these for the competency. So I just want to go over, most of you, did most of you feel like you understood the two-factor thing, or was it kind of dicey and tricky? A little bit, kind of? Or not really? Didn't really understand it so well.
I was able to till we had to write out the conclusion, and then I couldn't figure out really what we were doing. I couldn't really figure out how to say it.
So let's just share and just review, but this you don't have to write down. It was the alcohol pills example. This is an example. Why can't we run a correlation on this? Yeah, you don't have continuous variables. I have 2 levels of this. I have 2 levels of that. No correlations. You have 2 manipulated variables. Alcohol level, 2 levels. Xanax, 2 levels. It's a 2x2 design. 1 dependent variable that's continuous. That is a 2-factor ANOVA. When you have a 2-factor ANOVA like this, you can look for how many total effects?
2 main effects in your interaction.
2 main effects in an interaction. To see if there's a main effect of pills, how would you go on the matrix? Across the matrix. You'd get the mean for no Xanax, which if you add up all those numbers, the mean is, 90? When you have Xanax, the mean is 50. If that's going to be a significant effect, you want those 2 numbers to be how? Far apart. Okay, same thing for the main effect of alcohol. Marginal mean 90, marginal mean 50. We hope those 2 things are very different. That would be a main effect. And then finally, is there an interaction? How can you figure out visually if there's an interaction? Yeah, you can look at the scores or make a little graph if the lines are very non-parallel. There is one. Look at the one line, 100 to 80, that's going down 20. The other line goes 80 to 20. Very non-parallel lines. You could draw it out, so there's probably an interaction. I use this example because not only is there a statistical interaction, but there's also what? It's a drug interaction. You don't mix pills and alcohol here. So we showed you that. The other thing that we wanted you to do is the computation here. So if we look at the notes here, so that's the good picture. And, so the other thing that we showed you is how to actually compute the various forms of the numbers here. When we had a 1-factor ANOVA, what were the 2 key values for sums of squares? If it was a 1-factor ANOVA, we had variance between groups over variance within. Now, is it between over within? No, it's between. That's partitioned into the sums of squares A main effect, the sums of squares B main effect, and the interaction. So as opposed to having you do this stuff by hand, I gave you the between groups at 10,800. And if I give you the sums of squares for these 2 main effects, how does somebody get 1,200 there? You just subtract it. So you will not be asked to do these by hand, but you'll always get this and maybe 1 or 2 of the others. How about this one? How do you get the error? That one I want you to be able to do. How did we get a 48 there?
Sum of x minus x bar squared.
Yeah, you actually have to know that sums of squares within group thing, back from week number 2. So the idea here, how many sums of squares within 100, 100, 100? 0. They're all the same value. 78, 80, and 82, the sums of squares within that cell? It's 8. 78 minus 80 is the 4, and the 4 again, so you got 8 there. It's the same thing here, right? 8 here. And then finally, how much is this one? 32 plus 8 and 8, so you get a sums of squares within of 48. I expect you to be able to do that part that shows. How do you want these numbers to be? Do you want it to be close together or far apart? Close together within a cell, far apart between the cells. So most of you got this. And then degrees of freedom, you take the number of levels of alcohol minus 1, so 2 minus 1, 2 minus 1, interaction, it's just the same, 1. 8, because you have 3 in each group for the within group, so there are 3 in the first group, 3 in the second, third, and fourth. Then you get your variances for each of those. How did we get 800 for the main effect of alcohol? The variance due to the main effect over the 6. You want that number to be small, 800, 800, and 200. I gave you the p-values of 0, meaning that on the computer they would be significant. The part that just about everybody had some confusion on, and that you need to know if you want to write a note or two, you certainly can, is how to write this out, statistical and real world. Let's see if this is done properly here. I think it is, actually. So, for the main effect of alcohol, you could write F of A if you want. 1 and 8 equals 800, P less than 001. So you'd want to say when people had alcohol, it decreased performance. It decreased performance. You're making the statement basically that for the main effect of alcohol, these two numbers, the 90 and 50, it's saying that's a significant difference. When people had alcohol, they were poor. You don't talk about the cell means, you talk about the marginal means. So that's a main effect. When people took alcohol, they were 40 points less. You want to say the negative part as well. Was there a main effect of pills? Same thing. When people took pills, they were down. And then finally, the interaction. Was that significant?
Yes.
Yes, when people took pills and alcohol together, it really affected things as well. And I think, or it really caused a decrease. When people took alcohol and Xanax together, it caused a major detriment by about 60 points. So you make a real-world statement for each one. Last but not least, the homework problem. And just about all of you got the numbers here. You'll get something like this for the competency. 2 variables here. It's late, so I'll just cover this. 2 variables. We have race and salary. So 2x2 design. I think it was a public opinion type poll. I just made this up. I try to give you simple numbers, right? Because that just makes life easier. I give you the between groups at 12,300. I computed this with SPSS because God knows I didn't want to do this myself. If race and income add up to that, they add up to 12,300. That means the interaction is 0. What could you tell me about the lines in the drawing? They're parallel. This one goes 10 to 50. This one goes 60 to 100. Parallel lines. No interaction whatsoever. A 0 there. The error, whoa, 96. That is right. 6, 10, and 14, what are the sums of squares within this? 32, 32, and 32, and then no error in there, so it's 96. 8 degrees of freedom, you just go across, and most you got this. 625, 400, 0 there. And what, once again, threw a few people off. Let's see if we've got the statistical and real world. Down here, f of 1 and 8 equals 625, p less than 001. What would be the real world statement for that? It's making a statement about what? Race. What's the race statement? Non-Caucasians have what? Non-Caucasians believe the government should be more involved. So you'd want to make the real world statement. Non-Caucasians believe the government should be more involved. Is there a main effect of salary? Of income? Yes. What's the real world statement with that? The higher the salary, you'd have to get the marginal mean here and here. The marginal mean, it looks like, is 35 versus 75. The higher the salary, the less you think the government should be involved. Is there any interaction? No, the value is 0. You write f less than 1. You say there's no interaction. Whew, you guys did good. Okay.